What if I told you a telescope just captured over 10 million galaxies in a single shot? And that's only the beginning. This is not science fiction. These are the first shocking images from the Vera C. Rubin Observatory. Images that could change everything we think we know about the universe. High in the Chilean Andes, on Cerro Pachon, a machine unlike any other was built. A telescope so powerful, it can scan the entire southern sky every few nights. For 10 years straight, at its heart lies the largest digital camera ever built. 3.2 billion pixels, each designed to capture the faintest light from the farthest corners of space. The LSST cam, a camera unlike anything the world has ever seen. But why was it built? The answer lies in a mystery. Vera Rubin, the astronomer behind the name, provided the first real evidence for something we still don't fully understand today: dark matter. She noticed galaxies were rotating in ways that didn't make sense. They were spinning so fast that without an unseen force holding them together, they should have flown apart. That force was invisible. It didn't emit light, but its gravitational pull was undeniable. She called it dark matter. Today, we believe dark matter makes up over 85% of all matter in the universe. Yet we've never seen it directly. That's part of what makes the Rubin Observatory so important. On June 23, 2025, the observatory opened its eye for the very first time. Astronomers call this moment first light. It's the moment when a telescope begins to truly see the cosmos. And what it revealed was nothing short of spectacular. The first target, the Virgo cluster, a massive collection of galaxies, over 10 million of them, all gravitationally bound together. In a single image, the Rubin Observatory captured a piece of the universe so dense, so rich in detail, that astronomers are still analyzing it today. Before now, images like this took weeks, even months, to produce. Rubin did it in just hours. But that was just the beginning. The telescope then turned its gaze to two of the most beautiful regions in our galaxy, the Lagoon Nebula and the Trifid Nebula. Massive clouds of gas and dust, stellar nurseries where new stars are born. The images were breathtaking: vivid blues, fiery reds, and deep purples, revealing structures never seen in such detail. Each image was created by combining hundreds of exposures into a single frame. This technique, called stacking, allowed scientists to bring out faint details that would otherwise be invisible. And then came a discovery no one expected so soon. In just the first 100 hours of operation, the Rubin Observatory detected over 2,100 new asteroids. 7 of them passed relatively close to Earth. None were dangerous, but the speed of detection proved something important. Rubin could become one of our best defenses against potential asteroid impacts. Every 3 to 4 nights, Rubin will capture the entire southern sky. Over the next decade, it will create a time-lapse movie of the universe. Galaxies will drift, stars will explode, new objects will emerge from the dark, and we will have it all recorded in stunning detail. But its missions reach even further. One of its most intriguing goals is the search for Planet 9. For years, astronomers have noticed strange gravitational effects in the outer solar system. Certain groups of icy objects, called trans-Neptunian objects, move in unusual, clustered orbits. This could be explained by a massive, hidden planet orbiting far beyond Neptune. Planet 9 has never been seen, but the Rubin Observatory might finally change that. Rubin is also a detective, a dark matter and dark energy detective. We know dark matter is everywhere. We know it holds galaxies together, but we still have no idea what it's made of. Rubin's legacy survey of space and time will map billions of galaxies, measuring their shapes, distances, and movements. This will give scientists new clues about how dark matter is distributed. And then there's dark energy. While dark matter pulls galaxies together, dark energy pushes them apart. It's the force driving the acceleration of the universe's expansion. Rubin will help measure this expansion with incredible precision. Over 10 years, we'll see how galaxies move and drift. This will help refine our models of the universe's fate. All this may sound like pure science. Rubin's discoveries have very real implications for Earth. Its ability to detect asteroids quickly is a critical tool for planetary defense. In its first 100 hours, it spotted over 2,000 asteroids. That number will grow into tens of thousands over the next decade. If even one asteroid poses a threat, we will know sooner than ever before. And time is the most important weapon we have. The reaction to Rubin's first images was global. From universities to science centers, from massive public gatherings to quiet moments alone in front of a screen. Over 28 countries held watch parties. People watched as the first images appeared. Some saw their first galaxy, others cried, realizing they were looking at light that had traveled millions of years just to reach us. Behind all of this is the incredible technology of LSST cam. This camera is the size of a small car. Its lens is over 1.5 meters across. It can capture an area of the sky 7 times wider than the full moon in a single exposure. Every few nights, it will produce 20 terabytes of data. That's the equivalent of a decade of Netflix streaming, captured in less than a week. Rubin is not just an observatory. It is a data factory, a cosmic storyteller, and over the next 10 years, it will reveal secrets we can barely imagine today. But there's more to Rubin than just the technology. There's a legacy. Before the massive camera, before the advanced software, there was a woman with a notebook and a question. Her name was Vera Rubin. In the 1960s and 70s, Rubin was one of the very few women working in professional astronomy. At the time, observatories often refused to admit women. She faced rejection, discrimination, and skepticism. But she had something powerful: persistence. Rubin studied how galaxies moved. She measured the rotation speeds of stars at different distances from galactic centers. And what she found didn't make sense. The outer stars were moving far too fast. According to gravity, they should have been flung into space. Unless there was something unseen holding them in place. This invisible mass was everywhere. It wasn't made of stars, planets, or gas. It didn't emit light, but its gravitational pull was undeniable. Vera Rubin had just provided the strongest evidence yet for dark matter. Today, dark matter remains one of the greatest mysteries in science, and the observatory that bears her name is designed to continue her work. By mapping billions of galaxies over 10 years, Rubin will help refine our understanding of how dark matter shapes the universe. Rubin's legacy is more than just science. She changed the culture of astronomy. She fought for equal access to observatories and research positions. She mentored young women who would go on to become leading scientists. Her story is a reminder: science advances when everyone has the chance to look through the telescope. As the Rubin Observatory moves forward, it carries not just her name, but her vision. In the next decade, we will see discoveries she could only imagine. We may detect new planets. We will track the dance of galaxies in ways never done before. And we will inch closer to understanding the dark matter she revealed. A Rubin Observatory is more than a telescope. It's a promise to keep watching the skies, to capture every change, every shift, every secret the universe tries to hide. For the next decade, night after night, this observatory will create the most detailed record of the southern sky ever made. It will track the motion of billions of stars, record the births of new supernovae, catch asteroids as they race past Earth, and search for new worlds. Hiding in the shadows, but the impact of Rubin goes far beyond science. It is inspiring a new generation of scientists, engineers, and dreamers. Children who see these images today may be the astronomers who make the next great discoveries tomorrow. In over 28 countries, from massive watch parties to quiet moments alone at a computer screen, people are realizing just how vast and how fragile our place in the cosmos truly is. And while the universe is unimaginably vast, Rubin reminds us of something profound. We are connected to all of it. Every galaxy in Rubin's images, every star, every planet, is made of the same elements found in us. When we look into the universe, we are also looking back at ourselves. The Rubin Observatory is just beginning its journey, but already it has changed the way we see the universe. And if the first images are this incredible, imagine what the next decade will reveal. Are you ready to see what comes next? Then don't just watch from the sidelines. Join the journey. Subscribe now because the universe is about to get a whole lot more interesting.